In this scenario, a small apartment complex is currently renting 20 apartments at $1,000 per month. After some research, they have found that for every $200 increase in price, other property management offices have lost one tenant. They want to use this information to determine what is the optimal amount to charge in rent per month to maximize the apartment complex's income. How many apartments would they be renting when charging the optimal price? What is the maximum amount of income that can be earned in this scenario? In order to answer these questions, we need to break our scenario into pieces. First, let's notice what their current income is. They have 20 apartments that are being rented for $1,000 per month. So the current income would be 20 times 1,000. That is going to change with every $200 increase in price. So we need a variable to represent the number of $200 price increases, and that letter is P. Now let's look at how each part of our original equation will change with the price increases. With each increase, they will have one fewer tenant, so we can say 20 minus the number of increases. With each increase, the rental rate will increase by $200 for every price increase. We can now create the new model for our scenario, and that is 20 minus P times the quantity 1,000 plus 200P. You can see that this is a quadratic because we will be multiplying P times P to get P squared. The first question was, what is the optimal amount to charge in rent per month to maximize the apartment complex's income? We are looking for the maximum of our parabola, and in order to do so, we're going to look for the vertex. We could find the line of symmetry like we did in the previous video, but this time we're going to use the process of completing the square to determine the p-value of our vertex. First, we need to expand our factored form into standard form by multiplying our binomials. So we multiply each of the first two terms by each of the second two terms. We simplify our equation and we change the order of it so that it follows the normal standard form of the equation. To complete the square, we need to factor negative 200 out of all three terms. Once we do so, we can see that in parentheses we have p squared minus 15p minus 100. To find the number in our perfect square, you know to take the b value, negative 15, and divide it by 2. That gives us negative 7.5, so vertex form would look something like negative 200 times the quantity p minus 7.5 squared plus or minus some number. However, we can't use 7.5 in this scenario because we can't have a partial apartment rented. So knowing quadratics, we know that either 7 or 8 will produce the same maximum income. And I chose to use 7, but you could have also used 8. Now we know the ideal p-values of 7 or 8 increases, so we can, to find the maximum rental per month, plug 7 or 8 into the rental value part of our equation. 1,000 plus 200 times 7 price increases produces an optimal income of $2,400 in terms of rent per month. With that information, we can answer the rest of our questions. How many apartments will they be renting? Well, with 7 price increases, we will subtract 7 from 20 to determine that they will have 13 apartments rented. Finally, the maximum income can be determined by substituting 7 into our original equation. And you can see that we're just multiplying 2,400 times 13 to produce a maximum income of $31,200. We can check our answer by graphing our equation, and you will notice the starting income of $20,000, you will see that the Vertex is at approximately 7.5, and so 7 and 8 will produce the same optimal income. And after 20 price increases, they will have no income because they will have no apartments rented. It is interesting to note that while they will have 7 fewer apartments rented, they will have increased their income by over $10,000.